Hello everyone, I'm Milena, and this is our introduction to R and our studio session. You're going to be using R and R studio in this course. So here is tonight's agenda. We're going to discuss what is R and R studio. We're going to talk about the R studio environment and the interface. We're going to talk about how to save all your commands in R script. We're going to talk about variables. We're going to talk about reading data from CSV file into R. We're going to talk about the data frame properties, data visualization, and more. All right, so let's go ahead and get started. Here is the data that we're going to use today, and it's tracking the if it's tracking the employee job satisfaction level when number of years since last evaluation, number of projects that the person worked on, average monthly hours, etc., and whether employee left or stayed in the job, right? So that's here. This is employer's information that we're going to be using as part of this demonstration, all right? And here is the source of the data set. Okay, so what is R and what are its advantages? R is a language for statistical analysis and data visualization. It's free, it's an open source, and it's available for different operating systems such as Mac, Windows, etc. It has excellent data visualization capability and advanced statistical method implementation. You may save your code in a script and share it with others. R is continuously growing. New packages are being released as we speak. There is more than one way to produce the same result, and R supports parallel processing. Okay. Now, does R solve all problems that we need? No. First of all, R does not have graphical user interface. It requires some effort and practice to learn, and you need to know how to read the help pages. R is unfortunately it's case sensitive, right? So then, for example, plot in the uppercase letters is not the same as plot in lowercase letters. It may not solve all data mining problems, data analytics problems that you're trying to solve. You need to keep updating packages regularly, and you must have the local admin rights, or at least local admin password, to be able to install R on your PC. Then R, of course, cannot be embedded into a web application. So that's another drawback, all right? Okay. So what do you need to install? You need to install the latest R version based on your operating system. There is one for Windows and there is one for Mac, different installation files. Then you also need to install the R Studio, and I'll tell you what it is. So first R, then R Studio, all right? Because R will run without R Studio, but R Studio will not run without R, all right? Now, what is R Studio? Well, we said that R does not have a graphical user interface. What is R Studio? It's an integrated developer environment, and it's going to simplify your learning by providing some toolbars, menus, right, for managing packages and plots. It supports the direct code execution, and it allows you to preview what's in your environment, right? But remember that, well, and also you can see the commands history, but remember that you need to do as much as possible programmatically because you want the work to be reproducible, right? Programmatically means by writing the code. So you're gonna install the RStudio. Let's look at what it looks like. When you first install it, you're gonna see these three windows, right? So here, this window is called the console window. You see the current R version, right? So at the moment, I have 4.3, which is the latest R version that is available today, right? Also, when you run the command, console window is where you're going to see the output. When you run the command is going to be echoed in the console window and the output. You're going to see your error messages and warnings in the console window, all right? But remember, not all messages in R are errors. Some messages are informative, right? What do we have in here? This is an environment. Environment is going to show you what you currently have in memory, all right? So see here, at the moment, my environment is empty. I don't have any objects right now, all right, because I have not done anything. Here is where the commands history. I have something in the history because I was just playing around, right? So just know it. Here is the commands history, and you can rerun the command from the history just by clicking on it and clicking on to source, right? Oops, that will copy the command to the script, and I'll show you what the script is. So let's not save for a moment. Or you can click to console. So here, for example, I have a command in the history that returns our version, right? And just run it. So yes, I can run the command directly in the console window, but again, the work is not reproducible when I do it this way, right? There's no way to rerun all commands at once, right? So I'll show you something we need to do. But first, let's go over what this panel is. First tab in here, this is called files. So you see the files that are located in your current working directory. Working directory is a folder where R is going to look at by default. When you're trying to save the code or when you're trying to read the data file, that's a location on your hard drive where R will look at first. Plots, this is here you're going to see the visualizations that you create. At the moment, I don't have anything great. Packages. The code in R is grouped into packages. Package is nothing but the group of code, and it could have some pre-installed some data sets. It could have some vignettes that provide some examples on what the package has, right? So package is just basically the grouping of the code and the data sets and etc. Right? Everything in R is organized in packages. There are two types of packages. System library, those packages are pre-installed when you install R. Then there is also user library. Those packages are the ones that you will install, right? As you're working on your assignment, you will be installing some packages that are not pre-installed, all right? So like, for example, here, see this base package, this is a system library, it's pre-installed. And if you see the check mark next to the package name, it means the package is loaded in the memory, all right? So here, that's what I did. But there is also, notice here, there is also the source window. What is this? This is when you save the code in a file, right? So how do you do that? You're going to go File, New File, and you're going to go select R script. So this is a source window. This is where you're going to type your code, and you're going to save the file. The file extension is going to be .r, all right? Then you just go and click on Save and save the file. Okay? Cool, so far so good. Now I'm going to close this. But what I did for you, I prepared the code that I'm going to discuss right now. What you need to do here, you need to open the file. If you know where to save the file, you just click on Open File and browse for it. But here, there is a little trick in here. Here are the recent files, the files that I had recently opened. So if I was working on my assignment yesterday and I don't remember where I saved the work, it's going to be here. You go to recent files, and I'm going to select this one. This is what I was looking at, right? Over here, you see a little message. Well, that's because I'm gonna show you what you need to do, because in the code I'm using the package, something from the user library that is not pre-installed. I was going to install it as part of today's demonstration. All right, let's go back here to environment tab right now. Here, the first set of commands return information on our environment. Well, r.version is the same as version. It returns the same output, and it's going to show you the current version of R that you are running. All right. So I have version 3. I have a version 3.4. Oops, 4.3. See this? That's my version that I have now. And here just patch name, and each version has its own name. It says nickname is already tomorrow. All right. Now here, this is going to return the information about my session, including some settings, right? Like for example, if the output is too long, after how many characters it gets cut off, etc. This command is going to return the current time. All right, so that's a timestamp. ls command is going to return what's currently in your environment. It's going to return, it's going to be blank right now because at the moment I don't have anything. I have not created anything. Similarly, you can run object command to return object in your environment. All right. Next command is called data. That will return the list of pre-installed data sets that are loaded in memory. Right. So here, this is a list of the data sets. And in fact, for your first exercise, you are using the data set called Iris. And the data set is located in package called data set. All right. So you're going to be using that data set for the first exercise, Iris data. And all of these packages here, all of these data sets here are in the data set package. Okay, so there is a package that gets installed, pre-installed, and it has all of these data sets. Okay. Now, you can use R as a calculator. For example, if I do 5 plus 9, it's going to output 14. You might be wondering, what is it bracket number 1? Everything in R is a vector. All right, so here it means that the row starts with element at position 1. The vector elements are numbered starting from 1. In R, the numbering starts from 1. All right. So here, but look at this. I did 5 plus 9, but my environment is still empty. Why? Because I'm not saving, I'm not assigning the results to any variables. I'm not creating anything, right? I just output, right? Here, I can just output the sentence, print command, right? Here is a little bit different. What I'm doing is that I'm creating a variable called x, and I'm going to assign 3 to an x. Now, see this is a less than sign and a dash. This operator here is an assignment operator in R. So I'm going to create x and I'm going to assign 3 to an x. And then to output what x is, I can do print x, or I can just type an x as a shortcut, right? Now remember that you can nest the commands. If you do something like this, I'm going to create a variable y, and I'm going to assign to 5, right? I'm going to assign to 5. But what if I want to do an assignment and also output what y is in the same command? I can put an assignment in parentheses. Well, that will do, it will create y and also will output the result, okay? Now, suppose, see, we need to learn how to manage memory, right, in R. So to do that, we need to remove the variable the object no longer use. To remove the variable from the memory, you're going to run rm command, and in parentheses, you specify the variable name. So I'm going to run this. This will remove x. If I want to remove everything from memory, here is the trick. Remember, ls command returns all objects in the environment, right? So I'm going to take rm and I'm going to pass that list as a parameter to rm. See, this list equals the output of what? Of ls, right? ls returns the list of what you have in your global environment, right? So I'm taking what you have in the global environment and I pass it as an input to rm. And it's going to remove everything you have in the global environment, right? Now, what if you want to see the R options, including the maximum output size. To do that, you're going to run the options command. All right. Here, this is a command clear the screen, right? So this is the same as Control L. Okay, pressing Control L simultaneously. But if you need to do it programmatically, this is how you do it, right? This command is not going to do anything at the moment because I don't have any plots, right? A history command displays the commands from the history. So for example, I want to see the last 5, I run history 5. And here we go, I see my last 5, right? Now, everything in R is a vector, all right? Everything is a vector. Now, suppose that I want to create a vector of numbers from 1 through 5. I want to have a vector of with elements 1, 2, 3, 4, 5. To do that, I can use combine command, right? Command C stands for combine, and I list my elements inside. So what that will do is it will output 1, 2, 3, 4, 5. I'm not storing it anywhere. I'm not assigning it to any variable. I'm just outputting it here, right? I can assign it to X. But wait a minute. Do I have to type 1, 2, 3, 4, 5? No, I can specify it this way. I can put 1 column 5. So that will assign the numbers 1 through 5. It will create a vector of the elements 1 through 5, right? So let's try that. I'm going to run this, and then I'm going to output. So that's X, right? X contains now what? 5 elements. The first element is at position 1, right? But suppose that I want to display only the third element. In the brackets, I specify the element number that I want to display. All right. Now, if I want to see the data type of the vector elements, I'm going to run the class command, class X, and this here, all elements are integers. Alternatively, I can run type of command, right? Remember, there is more than one way to produce the same result, right? Okay. Str command is going to show you the vector structure. In this case, it just contains 5 elements, 1 through 5. Well, do I have to have the vector of a consecutive number? No, I do not. In this example here, we have a combine command that creates a vector of elements 1 through 5 and then 8 through 10. Notice that we don't have 6 and 7. So I can list 1 column 5, comma 8 column 10, right? So that will it will create the elements 1 to 5, and then it's going to be 8, 9, and 10. Let's see what's going to happen. I'm going to run this, and I'm going to output. See, we always want output to make sure that we're getting what we expect. Now, I showed you earlier how to display one specific element. For example, if I wanted to see just the third element, I just type the vector name, and in the brackets, specify the element position. I can also see the subset, the set of elements. For example, suppose that I want to see the element 3 through 6. What I'll do in a bracket, I specify this 3, and then I put the column, and I put 6. That will output the elements at position 3 to 6. All right. Here, to output the data type of y, again, I can type class of y, and this is an integer, and I can see the structure of y. We can do what else you can do. You can multiply all elements of the vector, right? You can multiply. For example, in this example, we take our vector y, and we're going to multiply all elements by 2. Watch what's going to happen, right? So that y times 2, this will multiply all elements by 2. Next topic is sequences. So suppose that we want to do the sequence of 10 elements. We use seq command to generate the sequence. If you don't specify the start by default, you're going to start at 1. You specify here that you want 10 elements, and by default, the increment is 1. So this is supposed to produce 1 through 10. Let's go ahead and run this and see what happens. So this is as expected, it produced 1 through 10. Next example is you may specify the starting number. For example, here I specify 2 parameters. I want to start from 2, and I want to list 10 elements, right? So I'll go this here, and I'm going to output this W. So what's going to happen? See this? I'm starting from 2, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. And see this? So I ended 10, sorry. So see this? I want to end on 10. You specify the start and end number. So see this here? This is 10 elements start at 1. So if you don't specify the start, it's going to take it as 1. Then you can also specify the increment. For example, here I want to start from 2, stop at 10, and I want to increment by 2. There we go. And let me output. Okay. Now, next topic is getting help. R has excellent help system. All you have to do is you put a question mark and the command name, and you're gonna get here. This is a help page. Like as an example here, I type the question mark and I put the command bar plot. Here it tells me that the bar plot function is located in a package called graphics. Here I see the description and the function usage, right? Here are the input parameters that the function may take. And I've got some code examples here that I could actually practice. And the examples are done on pre-install data, okay? So alternatively, you may type keyword help and put the command name in parentheses. Suppose that you don't know the exact spelling of the command, but you know that it contains bar in the name. There is a command called apropos that you can use. And when you do that, you can run a search and it will return possible commands that contain bar, okay? Alternatively, you can run examples for bar plot, or you can search. You can search the web for the command, right? Now, for your first exercise, you're using the data from pre-installed package. However, starting from the second exercise, you will be reading data from the data file. So to do that, the first step is R needs to know where to read the data from. So what you need to do is you have to specify, you need to set the working directory. That's a folder where R is going to look for the file that you're trying to read. On my hard drive, I have a folder called datasets where I saved the data file for today's demonstration. To set the working directory, you need to run the setwd command, and in parentheses, you specify the path. Let me run this. To make sure that I did it correctly, I'm going to run getwd command, and it's going to output what my current working directory is. Please note that here, if you look at the console window, in this title bar, you see the current working directory. See, this is the path here to the current working directory. It shows here, okay? Now, list.files command is going to return the files in your current directory. Here is a way to check if the file with a given name exists, right? So I'm going to check if this file exists. Well, sometimes if you get an errors with reading the file, you want to make sure that you have the file, right? That's the first step. Next thing is the read CSV command. Read.csv command allows reading the data from CSV file into our data frame. So here's the first argument. I'm going to specify the first argument as what? The file name, right? Next argument, header is true. It means that my column headings are in the first data row in the first row of the file. If I open up the file, the first row contains the column headers. If you don't specify it to true, then R, we're going to add its own headings, right? Which are not descriptive. You don't want this. You want to use the headings from the file. Just in case, I specify the separator as a comma, and you need to specify as is to false, because you don't want to be some of the columns here. You don't want to be read as a string. You want to be read as a factor. There are some columns here that if you don't specify as is set to false, get read incorrectly. So you have to throw it in there. All right. So now let's go ahead and run this. Okay. I'm gonna run now command to read the data from the file into the data frame. HR, here, this is a data frame. And in here, see this, it got added to the environment. I see the number of observations and the number of variables. Variable is also a column, right? It's okay. So here, if I click on the error, I'm going to see the column names. I'm going to see the data type for each column. You have columns that are numbers, the integers, right? And you've got the factor. Factor column has a predefined number of values. Like for example, department, there is a predefined number of departments, right? And the same thing is salary in this data. It's a factor, it's low, high, and medium. So we don't want these columns to be read as string. So that's why as is set to false. Right, so I write this is a structure, and we're going to look at it programmatically also. But if I want to preview my data in a spreadsheet view, I'm going to run the view command, and it will open data in a spreadsheet view. And I can, of course, if I want to, I can sort data and etc. You can play with this, you can filter it and more. Okay. Now, to see, this is going to be your friend, this command. Because to see the first 6 rows in the console, you just run head command. Head command returns by default the first 6 rows in a specified data frame. First 6 is the default. If I want to see 10, then I have to specify the number of rows. Is it here? Well, take a look at this. The output here, the number of columns, all columns don't fit in a window. So the output kind of like wraps. So just know it's because the window is not wide enough now. Okay. Well, this one tail command is going to return the last rows. If you don't specify the number of rows, it's going to go 6 by default. All right. But if you want 10, you want to specify 10, right? Now we're going to talk about the data frame properties. We read HR data, we read the data file into HR data frame. When you run str command, it's going to show you the data frame structure. What do I mean? It's something similar to what we just saw in the environment. You see the number of observations or number of rows. Then you see the 10 variables or 10 columns. Here are the column names and their data type. But notice that factors, levels. Level is the value that this column may take. Like for example, see this accounting, HRs, right? So here you have a list of valid values. And all of this, like see here, number 8 means that the first element, the first row in the data has the value is the 8th element in this list. See, like maybe it's easier to explain it here. See this? This is the salary. The factor has it has high, low, and medium 3 values. The value in the first row is low. So see that it's second one. The value in the second is medium, right? Because it's here. See? So now I can also check the data type of the data frame. Right? If I run the class command, it's going to return that it's data frame, data type. And then here, this is how I check if it's data frame. All right, is data frame. it's going to return true if I'm looking at the data frame. There are several ways to display column names programmatically. One way is a names command. It's going to return the list of column names. Now, take a look at this. Remember, everything in R is a vector, including output. Notice this number in the brackets. In the first row, the first element starts with position 1. In the second row, the first element starts with position 5. In the third row, the first element starts from position 9. You see this? That's what you see in here. Okay? Now, but this is, it shows a column name. Alternatively, there is a call names command to do the same. Okay? So this is how you get the list of column names. Well, sometimes you have to use the output of this command as an input to another. So you have to know how to get the column names programmatically. Sometimes you may want to loop through the columns in the data, right, and do something. So just know that. DIM command is going to return the dimensions or number of rows and number of columns, all right? But remember, the output of DIM is what? A vector of 2 elements. First element is number of rows, and the second element is number of columns. So now, how do I display just number of rows? Well, I can use nrow command, or I can use my DIM command and take only the first one, first element. Because this DIM returns 2 elements. It returns the number of rows and number of columns. If I do this DIM, HR, and I put 1, I'm only returning the number of observations. Okay, to get the number of columns, you can do ncol command, you can do lens, or similarly, you can do run DIM command, dimension command, but in a bracket, you specify 2 instead of 1, right? Alternatively, you can do the length of, well, here inside the command names HR returns the list of column names. And I'm taking the length of the list of column names. All right. Well, I threw it in there just in case you see it in the book somewhere. Okay. And it shows here that there are 10 columns in the data. Now we're going to look at the descriptive statistics. Summary command is going to return the descriptive statistics for entire data set, all columns in the data. See this? I have my 10 columns here, but remember, because the columns are different data types and the statistics are different for different column data types. For example, do you see this? Department is a factor and salary is a factor. For factors, it's going to show the dominant values and the number of rows that have which value. See this, like for example, here, this is the number of people who work for sales department. But please note that by default, it only shows the top 6 and everything else is grouped into category called other. So other is everything that is not sales, not technical, not support, not IT, not product management, and not marketing. It groups it into others, right? For the numeric columns, it's going to show the minimum, first quartile, median, mean, third quartile, and the maximum. That's what it does, okay? Notice that here in the department column, it only shows the dominant 6, but I can change it. I can specify max sum. Max sum option allows to specify how many levels you want to show for factors. So I'm going to run this. See, this is now showing 9 instead of see, now it's showing 9. Another thing is that please note there is something called NA in here. We're going to talk about later, but NA here shows that there is a 1 row. It's missing a value in this column. And then there is also 1 row that missing a value in this column, last evaluation. All right, we're going to talk about missing values soon. Now, there is an alternative. See here, we just looked at how to display the summary for all columns. What if I'm only interested in 1 column? No problem. I can type the data frame name followed by the $sign, and then you put what the column name. Let me run it. Oh, and very important, I forgot to tell you, what is this? Start with a hash mark. Those are the comments in R. All right, this is a single line comment in R. Start with a hash mark. Comment is not executable piece of code, but it tells what your code does. And it's very helpful if you have to revisit the code later, right? So it just showed the summary statistics for one column that I specified. Alternatively, what you could do is you can run lapply command, and you pass the data frame HR, and summary is a function that you want to apply. And I was going to do the run. See this? It's going to show me all of the statistics for all of those columns, except the output looks differently, right? It shows in a row instead of in a column. If I want to see just the minimum satisfaction level, I can run minimum command, min, all right? Range command is going to return both minimum and maximum. SD command returns the standard deviation. Unique command is going to return the unique values. Like, for example, unique department. What are the unique values of the department? Right, that's levels. You can do it by running levels or by running unique. There are two ways to do it. Here, it's showing the higher satisfaction level per department. See this? So I'm taking the satisfaction level. See this? I'm aggregating it and I'm specifying the function max, and it's taking the satisfaction level per department. So let's run this one here. Run, okay. Now, we're going to look, next topic is a subset. What is a subset? Well, you have a data frame, right? Suppose if you want to look at only the first five rows, the first 5 rows and the 3 columns. What you do is, well, you have to put in the brackets. First, you specify the rows numbers that you want to look at. Like in this example here, 1 through 5, comma, and I want column 1 through 3. I'm going to output, right? Here, in this case, notice that I specified the first 5 rows, but I omitted the columns. In this case, the output will return all columns. And the first 5 rows, but all columns, because I did not specify the columns that I want to see, right? Well, here, this is a way to run the code to return the first 5 rows and first 3 columns, right? Here, this is just another way where you're trying to look at the column names, right? So let's run this one here. Here, you're taking the column names and you're taking the first 6, right? HR. You display in the first 5, and then you're taking the scissors names HR. Yeah. So this one here, suppose that the elements that you want to select are not consecutive. What are you gonna do? Well, not a problem. You can use combine command, and in parentheses, you're gonna specify the position that you need, okay? So here you want to do the first 5 rows, column at the position 1, 4, and 5, all right? So here, this is just the column, right? First 5 rows, and those are the columns. Here, it will return all rows because I omitted specifying the rows, but I specify the columns that I want to. I'm using the combine command to specify the columns. Okay. Now, next thing is here, I can just take HR and I can take the salary. So that's going to be the first. I can display the first 4 values in the salary column. So how I'm going to do HR, then put a $sign. This is a column name, and this is the element index, right? Here, suppose that I don't know the column position, but I know the column name. So what you can do is you can use combine command to specify the column names in here. Okay, so I'm gonna run this now. Ooh. And in this specific example, it did not specify the row number. So this will pull all rows, which I don't want to do that now. Here, this will show the first 4 values in the salary column. Notice this, HR, then you have a $sign and a column name. So you're working already with specific column here, right? You can also specify the filter, which rows meet the selection criteria from the data frame. Like for example, here, I specify salary is medium. I want to see only the rows with the salary equals medium, and I want to see all columns because the columns list is omitted, okay? So let's see what's gonna happen. It's here, right? Medium. Now, here you can combine the conditions. For example, I want the department to be HR and I want the salary to be medium. Okay, you can do that. You can also add new column. Very simple. You put the data frame name, a $sign. This is the name of the new column. In my case, I want to add the calculated column to calculate how many months were spent in the company. So I take the number of years multiplied by 12. And this is an assignment operator. So let's see. I'm going to run it now. Right? So this edit a variable called month spent. How do I know? Well, multiple ways. If I run head command, I will see that column, right? If I run head command, I should see this column. It should be month spent right here. See this? To delete the column, you just set this to null. So you put here the variable name, the object name, right? The data frame name. You put here months spent, right? And you're gonna set it to null. That removes the column from the data. Okay, so you run this. And then here you can run head command to verify. Next topic is sorting. Why do you want to sort? Well, sometimes you need to select top 5 or bottom 5, right? It's much easier when the data is sorted. Then sometimes sorting can help you identify the duplicate data, all right? So what we're gonna do in here, we're gonna take HR, we're gonna create data frame, HR sorted, and we're gonna see here, this is taking a subset of orders, right? So let's see what's gonna happen. Run. Okay, I'm gonna type this. Now here, this is how to sort descending. You need to specify the minus sign right before HR. Here you need to specify to sort descending. See this? So let's see if it's gonna work. I run this. Okay. And then this is after 2 variables. And again, checking this, right? Next topic is a factor variables. So how do we convert attrition column to a factor? Note that attrition column is not a factor. We need to convert it. So how do we do this? Factor command will return the factor, right? So we're gonna, oops. So you have to do the another gift by, right? If you want to get more wilds or so. But what is happening is, so see here, make sure that you know how to read this. Then we're gonna run this summary command to see if nothing has been ruined, okay? So that's why you're going to run the summary command to make sure that nothing was ruined. Now here is how you would get the frequency count. You use a table command to get the frequency count, right? Okay, here it is. It's just the frequency count. You use the prop command to show the proposition, right? You want to see the yep. Now here this is gonna show the cross tabulation. It's gonna be, see this, I'm gonna run this one. I'm gonna run this one. So see this? I just ran it and it's gonna show me, see here, the first number here is showing me the 0, right? So the employee state and the salary. This is high, low, medium. Well, yeah. See here? Now, the next topic is missing values. Well, sometimes, once in a while, you might find the data set missing a value. It could be the data entry glitch or it just happened. Some of it you can solve by yourself, most of it, I would say. So, what is the first problem? Well, first of all, when you, so by default, some summary functions produce the default values, such as 300 or 400, right? But in here, what happened was she probably needed to buy something from the store, right? So that's why yeah. But see here what I'm saying. Okay, now going down. So we talked about this, we talked about that, and we talked about what you need to wear, right? Trying to find now. So next here, I showed you how to do the proposition table, right? Oops. And we are now on missing values. So, but take a look at the problem. This column, last evaluation, has a missing value. I'm gonna try to run this column. I see what and A. Nothing happened. Why do you think nothing happened? Well, I was storing anything here. We don't have anything, right? So now, so here nothing happened. And now I'm gonna run this again, right? Now I'll go back and I'm gonna run this. This is easy stuff, right? I'm gonna run this. Now, well, we want to display which rows have at least one column with a single value. This is the code here, how you would do that, okay? Now, next thing, oops, we did that. So, 1 second, sorry. So here, you can, well, I mentioned earlier that the data has missing values, right? So what exactly can we do to handle those missing values? Well, first of all, is to do nothing, but then the problem is a lot of stuff on the chain could be cancer. So, you still have to watch out. Anyways, so you have the average monthly, yes, you have to Oscar users probably. Okay, next topic is installing and loading packages. Well, remember that packages are not available until they're loaded to memory. How do I know what is available for me? This is a command I run to see if the packages are available. Ooh, what is going on? Okay, I'm gonna go in here. I'm gonna type dataset and wait. Sorry. So so here basically, let's go back. I went over this part. We went over R script, right? So you have the button to edit R script, but you also want to close it, right? Close the R script before exiting. You want to exit properly. Okay. Next thing is running the script. Well, you have your W command in the script, right? And then to open multiple command to open multiple at once, you can just you can just use more than one, right? More than one, and then just use the filter. R allows you to run the entire script, right? The script output will appear in console window. Remember that. Then you want to make sure that you're adding comments to the code. So at some point, person who takes over the report adds that information. Okay. Now let's look at this here. R script. R script is a code. It's a file that contains the executable R commands and some comments with description on what the command does. So, as I said, I prepared the file for you today. So this is the introduction to R file. All right. We've got that piece. Next thing is, well, this piece here. You have to make sure that you don't have anything in memory that you're not going to use, right? So let's see. I'm trying to get into it and search, because earlier today I found the image that I was looking for, but today I don't see it. Anyway, well, so you have to go and okay, so we have how many? 1, 2, 3, 4, 5, 6, 6, right? Okay. Well, over here I just highlighted some examples. Okay. The is command, the combine command, right? It's in here. Next thing is plots. Well, if I just type the question mark and commenting, it's gonna take me to the nearest or page. You know. Okay, so basically here, well, plots are still empty because we have not plotted anything. I'll try to close it later. Next thing, talked about this one. You may use up and down arrows on the keyboard to browse through the commands history. Well, you can use just use the right. You may use the history command to view the specified number of recent comments in a history. You may also use the history panel to view and search the community history. You select the command and click the console, and then you're gonna read it. You will rerun the command for history. Now, next one. So you need. Well, I showed you where commands history is, right? Then you may also, well, so here, basically it's telling you that you also use the history panel to view and search the history. You can do two ways. One way is to look at the And see here, one way you're going to look at if with what is in your inbox, right? If you have any stashed, if you will, right? And then on the next run, you're going to clear the cache and earn more points. Okay. So let me go. Next slide. Next slide. Well, that's a command history, and I'm also spelling out the commands for the working directory here. So here is just summary of how to preview data. We talked about that. We talked about data frame structure, right? We talked about the properties a little bit, right? Such as like see here, number of rows, number of columns, etc. Right? So this one is next topic is a subset. Suppose that I want to select only a portion of the data set, right? Well, how do I do this? Let's go here. I'm gonna go in here and I see. The numbers have to add to 100, right? So if I was doing this, I would probably tweak a little bit, reduce the number of spaces to fit it in. Okay. Oh, the row is missing the last evaluation value. Oh, excellent catch. We're gonna look at it shortly. Well, okay, so that was data visualization. Okay. Next step is we're gonna look at missing values. Okay. Well, there are multiple ways to do this, right? So the easiest way to check if there are missing values would probably be, let me find this. I'm going to go to the history. Oops, what is that? History. Because I did not save the name. So if I go here, well, it's I'm trying to find it. Sorry, guys. Well, but let's go over other commands. This NA command is going to check if your data is missing at least one value. See this? Here is just showing the summary for the column. Over here, this is a URL where you can install the packages from if you have to. Here, libraries, it will install the pre-installed packages that are currently in memory. Search command, well, for some reason, it just did not do much now. Okay. Next one. Live pass command is going to show you where on your PC you are storing the R files. Okay. It returns where on your PC you're storing your files. Okay. So live pass. See this? One of them is in program files, another one is in the users folder. Okay. How do we install packages? We run install packages command and put the package name in parentheses. So I'm going to quickly install the package called rules. You will be using it for the association rules assignment and as well for the assignment 4, I believe. Pre-assignment 4. Okay. So now, well, I'll see here. Well, this is to run a rules method, right? Search is used for searching, not too much. Okay. Well, then a rules package also has a vignette that you can read about with some stories and some examples. Okay, here I'm just reviewing what I showed you. Hold on. We talked about the subsets, right? We talked about we talked about adding elements from the data frame, right? But we didn't talk about the removal. So I restored everything else to wherever it was before Wi-Fi removal. Okay. Now, I'm just summarizing how to delete, how to do stuff. Yeah, okay. Well, here is just a reminder on how to do statistics, right? Like first quartile, second quartile, etc. Right? Oh, here this is just sorting. Remember, I believe I may or may not have talked about it. You just put the you just want to sort the data frame. It could be useful to find the duplicates if there are any, and it could speed up the research since there's no need to search every instance. Okay. Well, here are some of the frequency count commands. This will show the frequency count. Table command or use is factor is levels. Now here it comes. Missing values. Some functions do not handle missing values. So if the value is missing, that's it, right? But it should, right? We use the command to check if data has missing values. The sum command checks how many values are missing. So some options for handling missing values include the removal of the team you're on right now. Then you would need to get the defenses and etc. Right? All right. So are we ready? Okay, packages. Our functions are grouped into libraries called packages. There's system library and user library, what you install. This in blue is the latest pages. Okay, well, this are additional commands, but one thing to remember is that a rules command will load the package in memory, but the code execution continues if the command returns error. For example, I might have this function inside another function, right? So the data will not be returned because you have a, that's it. If you missed, you missed. But anyway, I'm saying here, here is a list of alternative commands. Data visualizations. Remember that histograms and pie charts show the frequency distribution, and they do work well for the large data set. But it might not work for all data sets, who knows, right? Usually we use the pie charts to show the frequency distribution for categorical variables. All right? But it will show the percentage of total, right? Scissors and then next slide. These are the bar plots to show the frequency for categorical column. And the other one is just an example. It shows the relationship between two variables. Scissors, see how bars are changing? Yeah. Now here is just a generic plot command. It's just a generic, okay. Next one. I guess that was all I was going to say. Then there are couple groups in here, okay, that you may join. But well, let's go back to the code. I did not go over all code. I need to go over the missing values code. So let's go back. Well, here, this command is going to check if the data has any missing values. Is an A and put in HR. So if there is a missing value, then is an A is going to return true. See this? True, true. And then it's a brother, right? It's going to be true. Okay, I'm going to run here. You saw in the summary that there are several columns with missing values. Here you're displaying the observation if at least one column is missing the values. This is how you do this. I'm going to just run it. Okay. Okay, so here well, this is just creating the new data frame. I'm taking the HR and it's taking the completion date, and then it's taking age. I believe I saw it in the pet store. Okay. Next one. Oops, where is it? Try to find it. Okay, so we did that. I showed you how to do how to show how many missing values are in each room, right? So you just do, and I'm gonna click here. So everybody got one, right? Okay, so that missing values. Sometimes you may handle missing values by replacing them with variable min or predefined values. For example, there is a min here with one last evaluation, right? And the person does not have much coins. They're enough only to recover whatever it is on this account and to start and to play on another account. It's just too much, right? So please, I'm asking everybody to step up on quests. Now, what else is in here? This is a here is just how to take the subset of columns, okay? Right. So here, well, what is this? This is sort of like a log, and wait, yeah, it just shows. See here, it's okay. Let's go back to it. We are looking at the not the histogram yet. So we install here the rules package, and then we're gonna use that to get the 8 p.m. But so here, if I so here this code, this is basically it's setting the horizon value to true. See, and I'm sorry, it's changing. See this horizon plot bar, I order it ascending. That's what it does. It produces a plot and orders the elements ascending. Okay, so it's here now. Pie charts show the categorical columns, but you want to keep in mind that it's based on the data that you are looking at. When I look at it, maybe I get different. I have different data, right? So just know that box plot. Remember 5-number summary thing. So let me go in and run. So now I'm going back. Oops, did not want to do that. So now I ran this. Oh, did not want to do this. Okay, now box plot for numeric columns. Well, here there is a generic plot function. For example, HR salary here, it will display the categorical values. Here is it will display salary is 1 and type equals 1 and etc. Okay. Now, well, that's a whole, that's mostly here. What else did I not show you? Okay, so what you gonna do? Oh, to exit the RStudio, what do? You're gonna select the quit command, right? Okay, trying to find where they moved it. They moved this thing after reset, after upgrade. Sorry, no additions. I don't see it. Well, but the whole idea is that I need to be able to see. I won't be able to run it until I see that HR column. but please make sure that you run it at home and let me know, okay? All right. Well, do you have any questions on everything that was covered today? Nope. If there are no questions, that I'm gonna call it a night, and good luck in this course.